All right, so welcome back. So here we've got another ALEKS topic. It's called Understanding the Organization of the Electromagnetic Spectrum. I think this is a really nice topic just to get us familiar with the electromagnetic spectrum and sort of relate some of the different properties of those photons. So the first thing that we need to do is really just become familiar or comfortable with this sort of graphic, I guess is one way to put it, because this is going to tell us all of the different types of electromagnetic radiation. So electromagnetic radiation is just photons. So when we hear photons, we're probably thinking about the light that we see, visible light, and that is one small aspect. So this little portion of this spectrum, that's visible light. So, the colors that you're seeing, if you look around you and you see red and blue and green or yellow or whatever, that is photons of light that have different wavelengths. That's why we perceive them to be different colors. That's how we're seeing color, basically, is the different wavelengths, the different energies of those photons. Now, we could have photons that have lower energy than visible light. So all of these things over here, they're still photons, but they just have a lower energy. They're outside of that visible range where we can actually see them. Likewise, we're going to have things that are higher energy over here. So just sort of highlighting a few of these things. Radio waves. So as you are driving in your car and you're tuning into a certain frequency of the radio that you're listening to, that corresponds to the frequency of that radiation of those photons that are being transmitted at that frequency. So that's really low energy. So AM radio waves are going to be sort of the lowest energy thing on this spectrum. Sort of moving, this way, we're going to higher energy. So this is low energy over here, high energy. Maybe we'll write that on there. This is low energy, and this side over here is the higher energy, which is somewhat sort of backwards or counterintuitive, but these are lower energy. Microwaves, the energy that's coming out of the microwave, we can't see those photons, right? But they're just actually at a different frequency, a different wavelength, energy-wise, than our visible light. But those are just photons. UV, so we've heard of ultraviolet UV radiation from the sun. Those are just photons. They're higher energy photons. That's why they sort of do damage or give you a sunburn, is because they're higher energy than those visible light photons. And then X-rays and gamma rays. So X-rays, you've probably heard, are bad for you. Again, the reason is just because high energy photons, hitting your skin or hitting your bones or whatever. So once we are familiar with this chart, with the different things that we're talking about, then we can do this ALEKS topic, where basically we're just sort of relating the energy of our different types of radiation. And that's really the key. So when I do this problem, I would start by looking at this column here, the order of energy. So I'm sure I get it right. So 1 equals the lowest energy or lowest frequency or lowest wavelength, and 4 equals the highest. So just looking at our table here, I notice red light and blue light. That's going to be in this little visible band. So red light's going to be here, blue light's going to be here. X-rays and ultraviolet, they're showing up on my table here. So X-rays are my highest energy photons that I have in this chart. So I'm going to put a 4 here for X-rays, a 3 for ultraviolet. Now for red and blue, we can sort of see on here, blue is more to the left, that's higher energy. Red is more to the right, that's lower energy. So red is actually the lowest energy visible. So in the visible spectrum, red is actually the lowest energy, and blue or violet is actually the highest energy within this narrow band, right? But these are still going to be lower energy than our ultraviolet or UV or X-rays. And then over here, these would be lower energy. So if I had something like radio waves, for instance, on this chart, radio waves would be the number 1, would be the lowest energy photon. The frequency is just going to match up exactly with the order of energy. So the energy of a photon is equal to the Planck's constant times frequency. So as the energy goes up, then the frequency should also go up. So the frequency should be the same, 1, 2, 4, 3. And the wavelength is going to be exactly opposite. So the wavelength will just be exactly opposite, 4, 3, 1, 2. And then the relationship between frequency and wavelength. So these are our 2 equations. C equals lambda times frequency. So the wavelength, this equation says the speed of light is equal to the wavelength times the frequency. So if one goes up, the other one has to go down. This is going to be a constant. And then the relationship between energy and frequency, as the energy goes up, then the frequency should also go up. All right, so let me know if you've got any questions about this. But really the take-home message here is that these are all photons. They're all types of light. We can only see this narrow band. We've got our orders for our energy. That's going to be the same as the orders for the frequency, and then the wavelength is just going to be the opposite. All right, cheers.